Hi, welcome to my channel pibyme Maths. This is by Devan. Here we are solving January-February 2021 Pure Math 2 paper. Let's look at question number 1. We have a function f of x given. There is a and b missing constants here. When f of x is divided by x minus 1, the remainder is 4. That means if you replace x by minus 1, you should get 4. That's a remainder theorem, right? So replace x by minus 1 here. Minus 1 to the power 4 plus a minus 1 whole cube, 3 minus 1 whole square, b times minus 1 plus 5 should be equal to 4. So that's 1 minus a minus 3 minus b plus 5 is 4. 6 minus 3 is 3, goes to the other side. Minus a minus b is 1. Multiply throughout by negative 1. You got the answer already, part A. Part B now. When f of x is divided by x minus 2, the remainder is this. That means f of 2 will be equal to minus 23. So in the function, I'm going to replace x by 2 now. So 2 power 4 plus ax square, ax cube, minus 3x square plus bx, minus 3x square plus bx plus 5 is minus 23. 2 power 4 is 16, 2 cube is 8, 2 square is 4, 3s are 12, 2b plus 5 is minus 23. So 16 minus 12 plus 5. 9 goes to the other side. 16 minus 12, 4 plus 5 is 9, goes to the other side. Minus 9, it becomes minus 32. 8a plus 2b. Divide through it by 2. You're going to get 4a plus b is minus 16. Take it as equation 2. We have equation 1 here. They want us to find the values of a and b. Solve the equation 1 and 2. I'm going to write equation 2 first. 4a plus b is minus 16. Write equation 1 now. A plus b is negative 1. Subtract them. 3a is equal to minus 15, a is minus 5. And then sub in a into any one of the equation. I'm going to sub in into the first equation. Minus 5 plus b is minus 1, b is equal to 4. That's all. Question number 2. A curve has this equation. Using calculus, find the x coordinates of the stationary point. To find the x coordinates of the stationary point, you need to differentiate with respect to x and equate it to 0. So x cube becomes 3x square minus 2x minus 16 is 0. 3 minus 2 minus 16. Minus 2, wait, 1. 8 over 3 and minus 2. X is 8 over 3, x is minus 2, but write a step here. Write it as a fact, so you won't lose them all. So we got the x coordinates already, that's all. Part B, justify by further calculus the nature of all the stationary points. Okay, we got dy by dx is equal to 3x square minus 2x minus 16. And we got 2x coordinates, 8 over 3 and minus 2. Now differentiate it again one more time to find the nature of the stationary points. You'll get 6x minus 2. So when you sub in x by 8 over 3, d square y by dx square is going to be 6 times 8 over 3 minus 2 is 2 8s or 16 minus 2 is 14 is a positive number. When you sub in minus 2, d square y by dx square is 6 times minus 2 minus 2. which is minus 14 negative. So this is local minimum, this is local maximum. That's how you find the nature of the stationary points. Question number 3 now. Solve this equation, write your answer in this format. Okay. 7 to the power x plus 2 is 3. You can write it as 7 power x plus times 7 power 2 using laws of indices. 7 square is 49, goes to the other side, 3 over 49. Now rewrite using logarithm, you will get x is equal to log 3 over 49 to the base 7. That looks exactly like this, where the question says a is a rational number. So 3 over 49 is a rational number. That's one way of doing it. Another way is just rewrite using the power, using the logarithm. You will get log 3 to the base 7 is x plus 2. Okay. So x is equal to minus 2 plus log 3 to the base 7, right? If you have a logarithm here, you can combine it to a single logarithm. So I'm going to write minus 2 as log 7 base 7, because log 7 base 7 is 1, right? Put this minus 2 as a power, 7 power minus 2, which is 1 over 49, plus log 3. Log a plus log b is log a times b. 3 times 1 over 49, you will get this answer. That's another way of solving it. Double I now. Use the laws of logarithms to solve this equation. So whenever they ask you to solve a logarithmic equation, the step number 1 is push all the logarithms to the same side of the equation. So log y plus 4 minus log 5 minus y is equal to, I'm going to push the number 1 to the other side. Combine the logarithm into a single logarithm. Okay, the bases are 2. If they are positive, you can multiply them. Negative, you divide them. Now rewrite using power. You can write it as 2 power minus 1 is y times y plus 4 over 5 minus y. 2 power minus 1 is 1 over 2, right? So you have 1 over 2 is y square plus 4y if you open the bracket. Now cross multiply. 5 minus y times 1 is 2 times this. Move everything one side, you will get 2y square plus 9y minus 5 is 0. Let's solve this quadratic. 2, 9 minus 5. You get 1 over 2 minus 5. 1 over 2 minus 5. You write it as 2y minus 1. Y plus 5 is 0. Even though we got two values, we need to check which one is the actual value. When you sub in minus 5 here, this becomes a negative logarithm. So you put a cross for this. For half, when you sub in here, it's positive. Here it's positive. 5 minus half is also positive. You don't need to show any working. Finally, you write therefore x is equal to, y is equal to 1 over 2. You have to write this, otherwise you will lose them all. Question number 4 from binomial expansion. They want you to find the first 3 terms. So 2 plus px to the power 6 is 2 to the power 6 plus 6c1. 2 to the power 5 times second term power 1. 6c2. 2 to the power 6 minus 2 times second term power 2. So 2 to the power 6, 2 to the power 6, 64 plus 6c1 times 2 power 5 will be half of 64. 6c2 will be 6 times 5 by 2, you will get 15. 30 over to 15, use your calculator. 2 power 4 will be half of 32 is 16 times p square x square. You will get 64. 6 times 32, 180, 92, 192 px. 15 times 16, 240 p square x square. That's all in part A. Part B now. The coefficient of x square is minus 3 over 4. Find the possible value of p. So I'm going to take this 3 minus half x. I'm going to write it as x over 2 times. Instead of this, I'm going to use the expansion from part A. 64 plus 192 px plus 240 p square x square. Okay. To find the coefficient of x, you will get the coefficient of x square. Coefficient of x square, when you multiply this and this, you will get the coefficient of x square. And you will, when you multiply this and this, you will get the coefficient of x square, right? So 3 times 240 p square minus x over 2. Just take the number 1 over 2 times 192 p. These two will give you the coefficient of x square. This is equal to minus 3 over 4. That's what the question says. Now we need to solve it. So 3 times 240 is 720 p square minus 9 2s are 18, 6, 96 p plus 3 over 4 is 0. Multiply through it by 4 to get rid of the fraction. 720 times 4. 2880 p square. 96 times 4. 384 p plus 3 is 0. And I'm going to solve this. 2880 minus 384 plus 3. 1 over 8, 1 over 120. 1 over 8, 1 over 120. So you write it as 8p minus 1. Don't skip this step, please. They want you to find the possible values of p. No other constraints given, so these two are the possible values of p. Question number 5. Use algebra to prove that for all x is greater than or equal to 0, this is this. I'm going to move everything to the same side. 3x minus 2 root of 3x plus 1 is greater than or equal to 0. Proving this is same as proving this, right? Can I write this as 3x as square root of 3x whole square minus 2 times 1 times square root of 3x plus 1 square. Does it look like a square minus 2ab plus b square? I did not put this symbol because that's what we are trying to prove. Okay, so this can be written as a minus b whole square. This expression can be written as a minus b whole square, right? A square of some number will always be positive. So I need to write square of this is greater than or equal to 0 for all x greater than or equal to 0, right? If this is true, automatically this is also true, automatically this is also true, because we derive this equation from here, right? Okay, so you can write therefore 3x minus 2 root of 3x plus 1 is greater than or equal to 0. Therefore 3x plus 1 is greater than or equal to 2 root of 3x for all x is greater than or equal to 0. So whenever you see an inequality, push everything to one side and just prove it as positive or negative depending on the inequality sign you have. Show that the following statement is not true. So we are going to use a counter example. Sum of 3 consecutive prime numbers is always a multiple of 5. Is always a multiple of 5. Okay, the prime numbers 2, 3, 5, 7, 11, 13. When you find the sum, you will get 10 multiple of 5. When you find the sum, 15 multiple of 5. When you find the sum, 23. So you can write 5 plus 7 plus 11, 18 is equal to 23, not a multiple of 5. Not a multiple of 5. That's all. You don't need to write anything. Just a 1 mark question.